I'm very excited to show you this new device that came out not too long ago called the I/O Expander. As you can see, it adds more inputs and outputs, 8 of each, to your pre-existing setup, and it also gives you some cool features with RFID, which we'll discuss a little bit later. But what you get in the box is what you see here, things like this. And you get these little feet that come here like this, and those get mounted into the sides, so these can be mounted to a board, screwed in, or if you look at the bottom here, it has the ability to have DIN rail mounts that get slid onto the bottom there. Now, I've already wired this up for functionality, and as you can see here, we have our Ethernet cable, and that is how this communicates over DMX over Ethernet here. So you plug this in to the DMX in, and then over here, this plugs in to the EXP expander port on your Flexmax 2 here. Even though this is DMX, you don't put it here into this, you put it into this. And that lets you communicate specifically with this here. Now, what's interesting about that is this actually gives you 2 chains of DMX. And this is not something they talk about in the manual, but it's something I've discovered talking to Fried Ideas here, that you can have a DMX chain coming into the in and outs here on this port, and a separate one here coming in and out here like this. So you treat this like a DMX fixture. And so you have 2 different DMX chains, but they still talk to each other as one, which is really nice. The other thing here I want to point out is you'll notice this has one of these pinouts that goes to the relay board, the 4-channel relay board, or an AC pack. And it's the same port that is on the side of the Flexmax here. Now, if you have never messed with those, they allow you to control relays or AC items from your outputs. Now, what'll happen is they come on at the same time. So you can control a DC 12 volt or 24 volt object from here, but also control an AC or relay separately with this at the same time. So that is really cool that you have this ability to do it here and here if need be. But this is the initial setup for your I/O expander. It just goes like this. So let's plug it in and see how it works. So when the I/O expander is first turned on, it runs a boot up sequence here, and you see the LED light up and do things. And one of the things it does is it tells you what the DMX address is here on the board. And this one, let's see, it'll boot up here, and it'll turn blue. The input 1 and input 2 lit up. So that means the DMX address on here is 12. And I'll show you how to set the DMX address manually here real quick, and then later I will show you how to do it in software, which is a little easier, but you need a director connect to do so. And one thing you'll notice right now is this green light is blinking very rapidly, and that means that the DMX is connected to the Flexmax and it's getting a signal. If it's not getting a signal, the light will be red. Like that, it'll be a solid red color. So all of the manual has a lot of this information in it and things like that, but that's neither here nor there. So I'll show you how to set the DMX address on the I/O expander here. So you have to hold down set while you plug it in, all right? And you'll get a blue light right here. That light has turned blue. And so now you press 1 if it's a 1, and it'll take that. Now I go 1, 2, and that gives me a 2. And I can keep going to a third number, but since I only want a 12 here, it then programs in that. So now the DMX address is set for this on 12. Now, of course, how do you know what the DMX address is? You're going to go into Director, and you're going to add this is a DMX fixture into the show, and it will auto give you the DMX address, or you can manually set it. But honestly, just let it auto do it, and it's fine. I'll show you how to do a single number here if need be. So let's say your DMX address is 5. So you just do this to 5. The little green LED moves across to 5, and now you just leave it alone. Don't touch it, and it will eventually figure out, oh, hey, there's only one number in this DMX address. So that is how you set the DMX address manually on this. And now let's go into the software and see how to do it that way, along with some other things. So let's set up a new show first. So go to our Flexmax, Flexmax 2, choose outputs here, choose your dimmables if you need any, choose your location, all that stuff right there, and create the show. And this is, of course, how the show will generally look whenever you start it, right here. So to add the DMX IO expander, you go to add DMX slave, IO expander, and I'm going to make one of them dimmable just so you can see what that looks like. Boom. And now that pops up, and here is our IO expander right here. This tells us the DMX address right here, so you can set this manually on the device, or if you have a director connect, like I do, you go to connect, DMX device utility, and it will detect your devices right here. So this tells me how many DMX channels each one of these has, is eating up. It also tells me the DMX channel of the device. And right here, it also will tell you the firmware. If you need to update the firmware on the IO expander, it'll be here. It'll say update firmware, and it'll say update firmware here in this little box right here. But we're up to date, so we don't have to worry about it. To set the DMX address, you can see here, I would click set DMX address. I would put the right one in, I would set it, and it would do its thing. So that's how you set the DMX channel via the director connect, like that. And that's pretty much it. That's really all you have to do. Now you treat these like regular outputs. Here's your dimmable right here. If you go up to your edit inputs, as you can see here, so you can edit the inputs. It'll tell you that the IO expander here, and these of course are labeled a little differently here, like the device input. It shows the device input 1 through 8, but it also shows just input 1 through 16 right there. So keep that in mind for when you're doing stuff. So like if you come up here to add an input, so input state here, you'll see boom, like that. And we'll say control and output, and of course there's our IO expander output. So if that turns on and that turns on, that gives you your inputs and outputs, just like that, just like a regular situation. They do not pop up down here in the legacy behavior because these are only for the older controllers and stuff, but the behaviors allow you to access them here like that. So I will now show you how to set up the RFID inputs. So now we're going to learn how to use the IO expander as an RFID interface. The first thing you're going to need is to pick up one of these boards from Fright Ideas. This is the one that they sell that works with this unit. You plug it into the RS232 port here on the right side like this, and that goes into there. Now you're also going to need some of these antennas, and there are 3 different kinds. There's these larger ones here, like this, that are 50 by 50 millimeters. And you've got these little smaller, skinnier ones, and you've got one that's a little smaller than this, but we're just gonna use these 2 right now. You're gonna plug this into here like this. And what's nice about these is they have a pretty long lead on them. Like these are very long. These give you a lot of length, which is pretty cool. So now I'm gonna plug the second one into here, like this. There we go. And that goes on there like that. So now we have these 2 antennas set up and ready to go. Now, one of the things that you wanna keep in mind when you're designing your props or whatever you're gonna need to is these 2 objects need to stay in close proximity of each other. They can't be too far apart. I did experiment with how far the length could be on these, and I got to about 3 feet before it really did not like it. So it's best to keep them as close as possible to each other, and then have this be DMX'd into your room controller far away, because DMX is made for longer runs than this protocol here that's being used. So keep that in mind when you're designing your props. Also to remember is that these are NFC tags, 13.56 megahertz chips instead of the typical 125 kilohertz that a lot of our props and we're kind of used to in other things. So that means you have to use these style of tags, whatever is available with the NFC style. And like we have a little key fob style here. We have your typical key card style here. This is a sticker. This is very thin, and the read range is not great on it, but if you have them stuffed very close to each other, it works great. And then there's these here that have a hole through the center, which allows you to mechanically attach them with screws into a prop or something like that. So these are really nice. So I will show you how to program these tags to the unit. I'm just gonna plug this in like that. And you'll see there's a little green LED here, so that you know there's power going onto the board like that. Now, what's interesting about this is you are programming the chips to the inputs on the unit, not the antennas. You're not pairing the chips with the antennas like you normally would, but it's going here onto the inputs. And I say inputs, it keeps track on the inputs, but it's keeping track numerically, chip 1, 2, 3, 4, 5, 6, 7, 8, whatever. And the reason for that is that allows you to do some really cool stuff with the RFID logic that we'll go over later in the software side. So to program these, you're gonna hold down the set button like this, and the status LED will start to blink blue. So now you're going to take these chips here and you're gonna touch them to the antenna like this, and that just lit up input 1, so that is now chip 1. And you'll also notice that when we touch this to the antennas over here, that light turns blue, so you know that it's reading it. And that now is chip input 2, like that. And again, it doesn't matter which one of these we're using, but you do want to make sure you use at least one of the antennas so it knows the antennas are in play. If you don't touch a chip to an antenna, it won't know that it's here in the system, just so you know. So there is input 3, and there is input 4. So I hit set, and now it saves those. So it knows what each one of these is. But if I touch this one to here, it lights up input 1. But if I touch it over here, it also lights up input 1. Again, because these are not being paired to the antenna. So now that we have that, they know what's what, and you can start your programming and doing your logic. Now, one of the things to remember is that if you push the set button down like this, it wipes all the tags and you have to start over and repair everything. It's just the way the system works, right? So we're going to repair, that's number 1, that's number 2. And we're just going to leave those 2 like that, and I'll show you why. Because I'm now going to program backup tags, right? These will be our backups. And what that is for is, like, let's say you lose a prop or something breaks or something like that. Somebody walks off with something. This allows you to have a backup prop or a tag in reserve, so you don't have to reprogram everything all right then and there, right? Which is really nice. So to do that, what you're gonna do is you're gonna hold down the set button, and the status button will blink blue once, and then you hold it down for about 5 seconds, and it'll start to blink blue twice fast. So there we go. So now it's blinking blue fast twice right there. So what I'm going to do is I'm going to put this onto the antenna, and that lights up input 1. And now I'm going to touch this tag to the same place, and now that input 1 goes off, which means this is now both input 1. That's my backup tag right there. So now we do the same thing right here. I'm going to touch 2. Now I'm going to touch this to there like that, and now that is both 2 like that. So then I hit set, and now we have backup tags in place, right? So if I was to take this and put it on here, that says that's a 1. If I put it on here, that says that's a 1, just like that. Same thing here, that's a 2, and that is also a 2. So you can only have one backup tag per tag currently. That's just, again, the way the system works. And maybe down the line, there'll be the ability to add more, but this is where we are right now. So this is how you set up your tags and get everything ready to go. And now we're going to hop into the software side, and I'll show you how to program the logic. Now I'm going to show you how to use this if you're using the RFID interface. So you go here to your behaviors, go to RFID, and this pops up this here. And so you have 3 different options: specific antenna, any antenna, and number of tags detected. Now, obviously, this over here tells you what all these things do, but I'll kind of walk you through it. Specific antenna is exactly that. A specific antenna detects or does not detect or is greater, et cetera, et cetera. There's some options here. And here's the number, right? So tag 1, or think of this as input 1, detected on antenna 1 would then control an output, right? Or something like that. If we go to any antenna, that's pretty obvious. Any antenna of any kind, it doesn't matter if you have multiples, any antenna detects whichever tag, it does something. And of course here, number of tags detected, it says here if there are multiple antennas, use this to count the number of tags currently detected. So you can use this as kind of a, these objects are sitting here, but it doesn't matter which ones, right? So it's like, oh, 4 tags are detected, do something, right? So you can be a little more vague, or you can be a little more specific. And that's pretty much it. Like, that's the basics of it. But what this allows you to do is tell certain tags to do certain things, but only after other criteria are met. And I will show you what I mean by that. So this example uses a premise from Metal Gear Solid on the original PlayStation. In that game, there were these things called PAL keys. And what happened is you had to take a key and you had to get it cold and then take it to a location. And you had to do it in a certain amount of time or the key would thaw out. But then you had to take the same key and then get it hot and take it to a location before it cooled off. And I thought, what a neat idea to use in an escape room, right? And so I wrote that logic here. You can see it here where I've made the RFID antenna 1 detects tag 1 and hot equals false. Then you set cold to 1 and set the timer to 15 seconds. And what'll happen is in 15 seconds, when that timer is expired, it sets cold to 0, which means nothing happens, right? So I'm going to show you how that works here on the monitor. So I've opened up my program monitor that can be accessed down here like this, and I'm going to start the show. So now the show is starting here, and you can watch everything happen over here on the picture-in-picture like that, right? So in this situation, we have our one key, our one thing, right? And what's going to happen is I'm going to touch it to the first antenna here like this. Now, if you look here down in the monitor, you see that cold has turned to 1, the timer is counting down, and the RFID antenna has just been detected, right? That's all it is. So what's happening is if this counts down and is done, this turns back to 0, which means when I touch antenna 2, nothing happens, right? Nothing happens. It just detects antenna 2. You can see how antenna 2 is turning on, a 1 or a 0. That's all that is, right? So if I touch it to here like this, the timer starts again, and if I can get it to this place quick enough, boom, it turns on output 1 over here, like that, okay? And now what's happened is we have the hot variable set for true, whereas originally it was set at false. So now what'll happen is I can take the exact same object, I can take this object here, and I can do the exact same thing, but it'll give me a different outcome, right? So I can touch this to here, and again, a new timer 2 has showed up, but if I touch it to here, like this, I get a different output turning on because I have now taken this to a hot location and placed it where it needs to go, like that. And that's pretty much it. That's the basics of how this works. So imagine you're doing some sort of interesting, like Minecraft type spell table thing, right? Let's say you need to turn this into a magical object. So what you would do is you would take this thing that turns into a magical object, you would set these in this one particular spot, like this, and then that would charge this and make it magic in some way or another. And now you have a third antenna over here, and you place it on this, and now stuff occurs. You forward your puzzle. But it won't work until you do this over here. Or let's say you had a science lab set up and you had 3 machines. And so this object has to go into this machine and it irradiates it. And then this machine, you have to place it into this one and it heats it up. And then only then can it go into the third machine to cause it to do whatever it needs to do. But if you put it in this machine first, nothing will happen. If you put it in this machine first, nothing will happen. It has to be done in a certain order. So this setup allows you a lot of flexibility and creativity when it comes to RFID and the things you can do with it by creating variables in the Director program and making flags and just giving you all sorts of cool creativity, which honestly we are looking forward to using and abusing. So that's how you use the I/O expander and the RFID boards. I'm very excited with all the flexibility this is going to give not only us, but also you guys as well. So enjoy that. And if you have any questions, obviously you can hit up Fright Ideas or just ask down in the comments and we'll do our best to answer them. So thank you and see you next time.